So our today's video is about the Prentice Rule. And Prentice Rule is very important in dispensing and optical lab management. So before learning about the Prentice Rule, we must have some knowledge about the optical center of the lenses. You know very well that there are two specific types of lenses, the spherical lenses. The first one is called the plus spherical lens, and the second one is called the minus spherical lens. And the physical difference, you can see, the plus spherical lens is thick from the center and thin from the periphery. In contrast, the minus spherical lens is actually thin from the center and thick from the periphery. So both of these are called the spherical lenses. This one is plus and this one is minus. So we are going to discuss about the optical centers. What is optical center? Optical center, you know very well that plus spherical lens is also called the converging lens. Why converging lens? When light ray will pass through the plus spherical lens, it will converge the light ray like this. But we have optical center in every spherical lenses. For example, exactly in the center, this dot is called the optical center, right? And what is the property of this optical center? Whenever the light ray will pass through this specific point, which is called optical center, it will go undeviatedly like this. It will not bend towards the periphery. It will go straight ahead. This is called the optical center, right? Same as in the minus spherical lens. Suppose this is the optical center of the minus spherical lens, and you know very well that the minus spherical lens is also called the diverging lens. So when the light ray will pass through the minus spherical lens, it will diverge like this. But when a specific light ray will cross through this optical center, it will go straight ahead like this. It will go undeviatedly. So this is called the optical center. The optical center is also called the sweet point of the spherical lenses. Why? Because the optics is very pure in this optical center. Because either it is plus spherical lens or it is minus spherical lens, the light ray which is crossed through the optical center, it will go straight ahead. It will not bend anywhere. It will not bend towards the periphery. So this is called the optical center. And now, before learning about the Prentice Rule, we will discuss a little amount of the decentration. So while dispensing the glasses to our customer or to our patient, you know very well we always mark the pupillary distance, the IPD, right? So these two dots, if you can see in these glasses, suppose these glasses are chosen by my patient or customer, so I marked the IPD, the intrapupillary distance, right? So we have discussed the two important points. You have to be very careful while you are dealing with the spectacles of the patient. What are those 2 points? Number one is IPD, the intrapupillary distance, the distance between the two pupil of the patient's eye, number one. And number two is the optical center of the powered lens, which we are going to order for the patient, right? So we have two different points. Number one is patient PD, which is actually the IPD, and number two is frame PD, right? So let's learn here. These are two beautiful eyes of the patient. This is nose. So what is IPD? IPD is actually, this is the center of the pupil. This is center of the pupil. The distance between these 2 points is called the patient's PD. Now we are going to put on the frame before the patient's eye. So this is frame. And for example, the frame PD is slightly temporal like this. This is patient PD, the center of the pupils, and this is center of the frame, for example, this dot. And this dot is also the center of the frame. And these 2 points are actually slightly temporal from the patient's pupil. So the distance between these 2 points is called the frame PD. So we have two different points. Number one is patient PD and number two is frame PD. The patient PD is actually the distance between the two pupil of the patient, right? Number one. And number two is frame PD. What is frame PD? The center of the frame, the center of the rim of the frame. So the distance between these 2 points is called the frame PD. How we can calculate the frame PD? We have a video, we have a detailed video on it. The link is in the description, you can see. So for now, we have two important points, patient PD and frame PD. Listen to me very carefully. Now we will discuss what is centration and what is decentration. When the frame PD and the patient PD will align together, the lens will be well centered and the patient will not face any asthenopic symptoms or any discomfort. The discomfort will there when the optical center of the lens, we have discussed about the optical center, the sweet point. The decentration will be there when the optical center of the lens will not align with the patient's pupil, and that is called the decentration. And when the decentration will be there, when in other way, when the optical center of the powered lens will not align with the patient's PD or the patient's pupil, when these 2 points will not align with each other, the asthenopic symptoms will be there, the discomfort will be there. In which form? In the form of prismatic effect. And how we can calculate that prismatic effect? We can calculate that prismatic effect with the help of the Prentice rule. So when we have discussed that either it is plus spherical lens or it is minus spherical lens, you know very well that if there is a plus spherical lens like this, so actually there are two prisms. You know very well about the prism. This is a prism, this is base of the prism, this is apex of the prism. And actually the plus spherical lens is a combination of two prisms which are attached base to base. So this is prism number 1. You can see this is prism number 2. This is 1 and this is 2. So two prisms are attached base to base. So that combination is called the plus spherical lens. And if we, in contrast, prism number 1, prism number 2. So two prisms are attached apex to apex in minus spherical lens. So either it is plus spherical lens or it is minus spherical lens. Both are the combination of the prisms. In case of plus spherical lens, the two prisms are attached base to base, and in case of minus spherical lens, two prisms are attached apex to apex. So in this case, this is the optical center. If the light ray will go through the optical center, it will go straight ahead, right? Because this is the optical center. And in plus spherical lens, this is the optical center. If the light ray will pass through the optical center, it will go straight ahead, no deviation, no bending. But if I slightly move this or this optical center upward, downward, inward or outward, then the prismatic effect will be induced, right? You know very well that if I put a prism before your eye, right, that prism will shift the image, right? So why this is shifting of the image is occurring? Due to the prismatic effect, because you are facing the prismatic effect, you are facing the presence of the prism before your eye, you are not looking through the optical center. So whenever the optical center is moved from your center of the pupil, you will face the prismatic effect. And how we can calculate that specific prismatic effect? With the help of the Prentice rule. So now we will learn about the formula, which is P is equal to H cross D, and sometimes we will write it down like P is equal to C cross D. It doesn't matter. So H mean the decentration and D mean power or the dioptric power of the lens. So let's put a question on it, on this formula. Suppose we have plus 4 spherical lens. The power of the lens is plus 4 and the optical center of this plus 4 spherical lens is moved towards the nasal side, right? Optical center is moving towards the nasal side. Power of the lens is plus 4. So as our lens is moving towards the nasal side, for example, so for decentration, so actually our decentration is towards the nasal side. So how we can calculate the decentration? Simple, frame PD minus patient PD is equal to decentration, right? So for example, our frame PD is 70, patient PD is 65. So when we will deduct 65 from 70, the answer is 5 millimeter. So decentration is of 5 millimeter. But remember one thing, when you are using the Prentice rule and you are putting the value of the decentration, that decentration value should be in centimeter, not in millimeter. So first we have to convert this 5 millimeter into 5 centimeter. So we will divide with 10 and the answer would be 0.5 centimeter. So our decentration is 0.5 centimeter. So we can say our plus 4 spherical lens is moving 0.5 centimeter towards the nasal side. And now we have to calculate the prismatic effect, right? So P is equal to prismatic effect, H is equal to decentration, and our decentration is 0.5 centimeter. It's 0.5 centimeter, and power of the lens D is plus 4. And now 0.5 into 4. So 0.5 into 4, the answer is 2 prism diopters. So if we have spherical lens with the power of 4 plus 4 and that specific power of the lens or spherical lens is moving towards the nasal side 0.5 centimeter, the prismatic effect will be two prism diopters. But in which side we have to move? It will go like base in, base out, base up, or base down. So for example, these are two eyes, and we have plus spherical lens, and because our lens is moving towards the nasal side, so because the center of the pupil is this, but the lens is decentered towards the nasal side, this is nose, so it is base in. You can see the base is towards the nose, so the direction will be base in. So we conclude that if we have a spherical lens of +4, if that spherical lens move towards the nasal side 0.5 centimeter, the prismatic effect will be two prism diopter base in. As you can see, our center of the pupil is here, and our lens is decentering towards the nasal side, so lens will be moved towards the nasal side, and it will create a base in effect. Now let's put another question. Now our spherical lens power is +5 spherical, and this time our lens is moving, that +500 spherical lens is moving towards the temporal side, right? And the value of the decentration is post frame PD minus patient PD. So frame PD is actually the same, so that will be 5 millimeter. We will convert that 5 millimeter into centimeter, and that would be 0.5 centimeter. So for example, we have established a question. For example, you are facing a question in your exams that a lens with the power of +5 spherical is decentered towards the temporal side, and the direction is temporal side, right? And what is the value of the decentration is 0.5. So what will be the prismatic effect? And also we have to write down the orientation of the prism. So how we can solve this? Decentration is 0.5 centimeter. Value of the power of the lens is 5. So 0.5 into 5. So that will be 2.5 prism diopter. So this is called the prismatic effect. But what will be the orientation of the prisms? Actually, our lens is moving, our lens is decentering towards the temporal side. So this is the center of the pupil, but the optical center is not exactly before the patient's pupil. It is towards the temporal side, and lens is plus lens. So in this case, you can see this is base of the prism, and base is outside here, right? So 2.5 prism diopter base out. So again, I can repeat it for you in just a minute. Suppose our question was, we have a spherical lens with the power of +5 spherical. We have decentration of 0.5, and that's +50 spherical is moving towards the temporal side. If the question is this, then how we can calculate the prismatic effect? How we can establish the orientation of the prism? So the prismatic effect will be 2.5 prism diopter base out. In this case, we will discuss about the vertical deviation. Suppose if our optical center is moving upward or downward from the pupil, right? For example, we have again +5 spherical, and now this time our lens is moving upward from the pupil. So decentration is suppose again the same, 0.5 centimeter. And how we can calculate the 0.5 centimeter? You know very well. So now we will put the values. Our decentration is 0.5. Power of the lens is +5, and the answer is 0.5 into 5, that will be 2.5 prism diopter. And what about the orientation of the prisms? So in this case, our optical center was moving upward. For example, the two eyes, this is a pupil, the center of the pupil, and our plus lens is moving upward. So if it is moving upward, so it will act like this. So this is the center of the pupil, and this is the optical center. So actually optical center is moving upward, so it will create the base up prism, base up, because you can see the base is moving upward. Now another question, if our power of the lens is same, decentration is the same, for example, and this time our lens is moving downward. Our optical center of the lens is moving downward from the patient's pupil. So again, decentration is of 0.5, power of the lens is 5, the prismatic effect will be 2.5 prism diopter. But what will be the orientation of the prism? And now our lens, our plus lens or optical center of the plus lens is moving downward. So this is center of the pupil, and now optical center is down here. So this is center of the pupil and this is optical center of the lens. So optical center is moving downward, and when the optical center is moving downward, actually it is creating the base down effect. So the prismatic effect will be 2.5 prism diopter base down. And now suppose we have minus spherical lens, we have minus 5 spherical lens, and the decentration is suppose frame PD minus patient PD, and frame PD is 70 again, patient PD is 65. The answer is 5 millimeter. We will convert that 5 millimeter into centimeter. We will divide it with 10, and the answer would be 0.5 centimeter. So in every case, our power of the lens is minus 5, for example, and the decentration will be 0.5 centimeter, right? So now we will put the examples. Now suppose we have minus 5 spherical lens, and that minus 5 spherical lens is actually moving inward from the optical center of the lens is moving inward from the pupil. So what will be the prismatic effect and what will be the orientation of the prism? So let's resolve this problem. So H is equal to decentration, and decentration you know very well, it is 0.5 centimeter. The power of the lens is 5. So 0.5 into 5, it's 2.5 prism diopter. 2.5 prism diopter is actually the prismatic effect. And now what will be the orientation of the prisms? So for this, let's learn. These are two eyes, this is nose, this is center of the pupil, right? And as our lens is of minus spherical, so and it is moving towards the nasal side, the optical center is moving towards the nasal side. So this is optical center, this is center of the pupil, and now this time, and as you can see, the base, this is the base of the prism, the base is actually out, right? So it will create base out prism. So if we have minus 5 spherical and decentration is 0.5 centimeter, then the prismatic effect will be 2.5 prism diopter, and the prism orientation will be base out. Now another example, suppose if we have the same power, which is minus 5, this is just for the sake of learning, right? We will put the same values, right? So our spherical lens with the power of minus 5 and the decentration is 0.5 centimeter, right? And this time the change is our lens is not moving inside, our optical center is not moving inside, it is actually moving towards the outside. So again, decentration is 0.5 centimeter, dioptric value power 5. So the prismatic effect will be 2.5 prism diopter. Now the orientation, two eyes, nose, this is center of the pupil, and as our lens is moving towards the temporal side, so this is optical center, so this is, you can see, the base in prism. So the effect will be base in because the base is towards the nasal side, so base in prism. So for example, if we have minus 5 spherical, decentration is 0.5, the prismatic effect will be 2.5 prism diopter base in. Now another example, we have minus the same lens, the power of the lens is same, which is minus 5, and the decentration is 0.5 centimeter. And this time, for example, our optical center of the lens is moving upward. Now we are discussing about the vertical deviations, and our optical center of the lens is moving upward from the center of the pupil. So for example, we have decentration of 0.5 centimeter, we have dioptric value or power of the lens is 5. So 0.5 into 5, the answer would be 2.5 prism diopters. But what will be the orientation of the prisms? As we have discussed that our optical center is moving upward from the pupil. So for example, these are two eyes, this is center of the pupil, you can see. So this is the optical center of the lens which is moving upward from the pupil. So as you can see, when the lens is moving upward, when the optical center is moving upward, the base will be in front of the eyes, so it will affect as base down, because this is base and this is downward, so the effect will be base down. And now the final example, and that is the same, power is the same, decentration is the same. The decentration is 0.5 and dioptric value is 5, and that would be 2.5 prism diopters. So that is the prismatic effect. And what will be the orientation of the prism? Again the same, and this time our eye is moving downward. The optical center of the lens is moving downward. So optical center is moving downward. So when we say it is downward, so the optical center is here, downward from the center of the pupil. So as the minus lens is moving downward or optical center is moving downward, it will cause base up effect. You can see this is base up effect. So the orientation is base up. That's all about the Prentice rule. You know very well that the Prentice rule is actually to measure or to calculate or to rule out the prismatic effect which is induced with the decentration of the spherical lenses.